Alright guys, today is a lot of review, but we're also going to talk about coterminal angles. So let's start with that. Um, so definition up here. Co, by the way, means with. Terminal means ending. So we've talked about an angle in standard position. It has two rays, right? It has two different rays coming out of that vertex point. The initial ray is on the positive x-axis, and then the other ray after the rotation is called your terminal ray. We're going to do a couple of examples here, and then you'll have to work through these, and then we'll get to the bottom section of this worksheet as well. So coterminal means angles in standard position that have a common terminal ray. Okay, so the directions here say identify at least two coterminal angles for each angle. If the angle's in degrees, give your answer in degrees. If it's in radians, give your answer in radians. So as you look through here, anything that has a degree sign, okay, is in degrees. And radians, you don't have to see the word radians after an angle to know it's in radians. If it's talking about an angle and it actually does not give a unit, you know it's radians. The default unit for an angle is radians. So if you don't see a symbol or a unit, like in these, I know a dead giveaway a lot of times is also the symbol pi, but it doesn't have to have a symbol pi in it to be in radians. Alright, so 120 degrees. You don't have to do this. You don't have to get a visual. I just supplied this here if you want to. But 120 degrees is 30 degrees more than 90. So I'll do my initial ray in red as I've been doing. So here's a ray on the positive x-axis. And 120 degrees is 30 degrees. Here's 90. So about 30 degrees past 90. I'm just trying to be accurate with the way I draw these. So here's your 120 degree angle. Alright, so we need another angle, at least two more angles that have the same coterminal ray. So the way we get there is we can do full rotations past that. So I'm going to give you a couple of examples here. So if we go 120 degrees and we go another full rotation past that, well, if we add a full rotation from right here, that's another 360 degrees, right? So I'll do this as scratch work up here just so I'm not messing up my answer area here. So if we take 120 degrees plus another full rotation, we end up with 480 degrees. So 480 degrees, I'll do the coterminal ray in a different color here. And I'm not going to do too many in the same spot because it gets kind of messy. So if we go 120 plus another 360 in green there, that's 480 degrees. It's 120, it's about a full rotation and a little more than a quarter of a rotation past that. So that's one way to do that. We could keep adding 360 degrees. So if we went to 480 and added another rotation onto that, what would that be? That would be 4840. So two answers here would be 480 degrees and 840 degrees. We could even, from this 120 degree angle, we could even go in the negative direction of a rotation. So we could actually subtract 360 degrees from that. So I'll do my work up here. What's 120 minus 360 degrees? Well, that's negative 240. And we could even subtract another 360 degrees from there. What would that be? Minus 600. All right, so we could be here all day long and forever, adding 360 to that given angle or subtracting 360. All right, let's go to the radians over here. So we have negative pi over 4. If you need to remember that conversion, again, I'll do my scratch work up here. If it's pi over 4 radians, and this is from yesterday's lesson, so if you need to go back and look at the video, do that. Pi over 4 radians, well, there's pi radians in 180 degrees. So that's my unit conversion there. So if I said pi radians for 180 degrees, remember I don't have to write the word radian to know it's in radians. And if we simplify this, radians over radians cancels. 180 divided by 4 is 45 degrees. So if you need to do that, this is negative 45 degrees though. So that's, here's our initial ray, here's our negative direction. So right here, I'm not going to write negative 45. I'm going to write negative pi over 4 there. Alright, so on this one, remember we were either, if we were going counterclockwise, we were adding 360 degrees, or if we were going clockwise, we were subtracting 360 degrees. Well, think about this. How many radians are in 360 degrees? Hopefully you're thinking 2 pi radians. So since this is in radians, if we want to add a full rotation onto this, we're going to add 2 pi. And if we are going clockwise in our rotation, we're going to subtract 2 pi. So I'm going to show you that work. And again, just scratch work up here again. Instead of 2 pi, I see the denominator as 4. So I'm going to think of 2 pi with a denominator of 4. What's that look like? 8 pi over 4. Think about reducing that. Isn't this the same thing as 2 pi? So our first angle, and I'll just show you both ways here, we could take negative pi over 4 and add 8 pi over 4. Well, what's negative 1 pi over 4 plus 8 pi over 4? Hopefully you're thinking that's 7 pi over 4. What if I subtract a full rotation from that? Negative pi over 4 minus 2 pi, right? That's 2 pi. But we needed a common denominator there. So negative 1 pi over 4 minus 8 pi over 4 is negative 9 pi over 4. And so that would be 7 pi over 4 would be here. And negative 9 pi over 4 would be here. Both ending on the same terminal ray. And we could keep adding or subtracting 2 pi to this. Okay, so the next 6 will be your practice there. Down at the bottom, review. It says graph each of the following angles in standard position. Be accurate, even if you are estimating the angle. So, like a 10-degree angle, here's the initial ray. For 10 degrees, you know it's going to be in the first quadrant, but don't just draw it like here. That's like a 45-degree angle. 10 degrees is like 4 times less than that. So 10 degrees is a tiny angle. Something maybe like that. Again, it says be accurate even though we're estimating. So that we're estimating a 10 degrees, but I feel that that's going to be pretty accurate. Let's do like one of these here. Pi over 7, the ones in radians. To get an accurate value, I would suggest converting it to degrees, because we understand degrees a little better than radians at this point. So how would I convert pi over 7 radians to degrees? I need my unit conversion here, and there are pi radians in 180 degrees. So this is radians, pi radians in 180 degrees. So the pi cancels out, and so I just have to figure out what 180 divided by 7 is. That's about a 26 degree angle. So 26, here's my terminal ray, or initial ray, and 25 or 26, well, here's 45, we did 10, so 25, 26 degrees is probably right around here, something like that. Close to a 30-degree angle. We think about our 30, 60, 90 triangles. And we'll be getting into those again here soon. Alright guys, here's your practice. I won't have office hours today because I have to go into the school and check out, but stop by tomorrow and we can talk this through.